This is Food Chemistry Unit 2, water, a universal solvent. So water. Why do we talk about water in food chemistry? Well, it is a nutrient, and nutrients are food components necessary for life. So we will discuss the 6 essential nutrients, each one at a time and in a lot of detail. So you have carbohydrates, lipids, proteins, vitamins, minerals, and water. So we're just going to start with water. So water is a main component in food. It influences texture, appearance, and taste. But you just have to be careful of impurities in water. This can alter physical and chemical characteristics. So for example, hot tap water, that can have calcium and iron deposits from the pipes dissolved in them. So maybe you want to prepare foods with cold tap water instead. So just know your source of water. All right, now let's look at some properties. The first property of water is called surface tension. So this is a force between molecules at the outside edge of a substance. So a good example is to think about a glass of water that is maybe overfilled, right? Like in this image here. So you can see that the water clings to the rim and will only spill if the force of gravity trying to pull it off that rim is stronger than the hydrogen bonds within the water, keeping it on that rim. So that's surface tension. Water also forms a curve or meniscus on surfaces like a graduated cylinder, which is a type of adhesive quality. So if you look at this image, right, you can see that dip in the water there. That's called a meniscus. So whenever you read a graduated cylinder, you always read the bottom of that meniscus to see how much you have. And then water also has higher melting and boiling points due to surface tension. And I have 2 great videos for you to watch about surface tension and how water acts. The first are the slow-mo guys. I don't know if you've ever seen them in their YouTube channel. So you're going to see droplets in slow motion, so that's pretty cool to watch. And then I have a great example of surface tension as seen by an awesome lizard. It's one of my favorite videos, so if you watch no other video, I highly recommend you watch this one. It's not very long, but it's just an awesome animal and a great video. And you're welcome if you do watch it. All right, but more properties of water. Solids like salt, liquids like vinegar, and gases like carbon dioxide in your soda, right, can all be dissolved in water. Flavor compounds from coffees and teas dissolve in water. Now the proportion of coffee and tea to water varies the strength and the flavor. The boiling point of water is affected by atmospheric pressure, and this affects cooking times. So the higher the elevation, the lower the boiling point, since there's less pressure. But this means that it takes longer to cook your foods. So here in Chicago, water boils at 100 degrees Celsius versus 96 degrees Celsius in Colorado, which is a higher elevation, for example. Now, pressure cookers allow this to happen, but right in your own kitchen. So the steam is released inside the cooker, and this increases the pressure, which increases the temperature of water inside the food, and then your food cooks faster. And I've got a great video, it's not that long, but if you're curious about the science of a pressure cooker, you can actually see one in the video, and the chef will explain why they're great to use, what it does for the food, and you'll also see how it works. Now you can raise the temperature of water when cooking simply by placing lids on pots. So the heavier the lid, the more pressure you can add and the more you can raise the temperature by as much as 5 to 6 degrees Celsius. But you've got to be careful. When that lid is removed, the steam is super hot. Okay, so let's look at the water content in foods. And these percentages should make sense if you just look at like the dryness of the foods, right? So fruits have 70% water, bread is 36% water, and popcorn is 4%. So yes, there is water in popcorn. It's a very tiny amount, but when you heat up corn kernels, that's how you get the popcorn, right? So you heated up that water, the kernel exploded and gave you the fluffy popcorn. Okay. So in foods, you have free water versus bound water. Now, free water is easily separated from food tissues. It can be easily juiced or squeezed. It will easily boil or freeze during processing and evaporates easily when food is dried. Now, bound water is tied to the structure of large molecules, and this makes it hard to freeze or boil. And it should make sense if you think of just the products I mentioned. So there'd be a lot more free water in the fruit compared to the bread. So bread and popcorn would have more bound water. And then we have something called a hydrate. This is a chemical compound loosely bound to water, one or more water molecules. So just one example for you would be the caffeine hydrate. And I just took an image from this website just to prove to you that it is real. So you have one molecule of water bound to caffeine, and it becomes anhydrous without water, which is what that means when the water is boiled off. So if you take the water off of that, it becomes anhydrous, right? It lacks the water. Okay, but this is real. It's a caffeine hydrate, so there's the structure. Okay, water activity. Okay, this is a value of foods. Okay, it's a U.S. federal government regulation. And so the water activity, it's the measure of the partial water pressure over a food. What the heck does that mean? It's the water available to support the activity of enzymes and microorganisms. So it's measured on a scale from 0 to 1. The higher the number, the more perishable the food. So examples include milk, juices, fish, canned, and fruits, vegetables. So if you just look at these, which would you think would have a higher or lower value? Well, the more perishable it is, the closer it's going to be to 1. And then I do have this guide. You're free to click on this. I will post the link, but I do have it here as well. So I just went to the U.S. Food and Drug Administration, and I mean, you can read through this if you'd like, but I just went down here to this list so you can see some examples, right? So like liverwurst at 0.96 or cheese at 0.95 versus dry milk at 0.7. So like a cheese spread or liverwurst, that would be more perishable than dry milk. So the number here is closer to 1. So that's what that means. Okay, so this is a U.S. federal government regulation. Okay, so we're going to end here by talking about your water supply and the fact that it should be safe. So like, where does your supply come from? Well, you have rain, right? That's a source of water, and that becomes part of rivers, streams, and lakes, or it filters through the soil into the underground water table. And the U.S. has tapped into this for its water supply. Now, one's wastewater often becomes someone's drinking water, and that can lead to health issues. Now, we have waste management here in the U.S., so our wastewater is filtered, right? So it hopefully does not become someone's health issue. But in less developed countries, this is an issue. And a common illness because of this is typhoid. So it's an illness caused by Salmonella typhi. That's a bacteria, and it's spread by animal and human feces. And it's often spread in heavily populated areas without proper sanitation. So oftentimes people are using the same water source to clean as well as to drink from. So that's not exactly the best situation. Oftentimes people cannot help this if they only have one source of water and there's no plumbing, so it's just a huge issue. Okay, now I just want to point out some other issues. The Mediterranean Sea along the Riviera, if you know anything about the Riviera, it's a very wealthy area, so a lot of people go there, but that means there's a lot of human waste in the water, and that makes it toxic to most life forms. Okay, even just think about Lake Michigan. If you think of the color of the lake closer to the beach versus farther out, right? Why does that color change? Why is it not as blue? It might often be like a greenish color, and that's because there's human waste in there because people go to the beaches. All right, then we had mercury that was dumped into rivers and oceans in the 70s, and then that mercury was found in swordfish and tuna. So again, I've got another website. It's called, oops, there's my science direct. Here it is. So I know that this is a lot to read, but if you can just scan through this, but you'll just see that mercury was a problem. It's often coming from a lot of industries, so it's been a huge problem. Hopefully we're stopping this, but I'm just letting you know mercury was just dumped into rivers and oceans, and then that gets into the food that we eat. In the 1970s, Lake Erie, not too far from us, there was a toxic buildup so bad it was called DEAD. Factory and human waste disposal reached toxic levels. And if you'd like to look at the history of that, I found a website about Lake Erie. It has since been cleaned up, but you can see why it was called DEAD. A lot of waste thrown in there. 1995 in North Carolina, dams holding 35 million gallons of hog sewage broke, polluting rivers and destroying fish populations. So if you're curious about that report, I've got that link as well. So you can see like what was happening, what was going on, why it was so bad. And then 2014, this is not that long ago, Flint, Michigan. And just FYI, they're still dealing with this, and this is 2020, right? In Flint, Michigan, the water source was changed from Lake Huron to the Flint River. A new pipeline was being built. They stopped using Detroit water, but in the process of this switch, coliform bacteria was found in the water, but the bigger story was the dangerous levels of lead in the water. So this has been a huge issue. So if you'd like to read about this, I've got a CBS Sunday Morning report on this. You can see the doctor who realized that something wasn't right here, and not to mention the fact that people's water was just, you know, brown and gross. They couldn't drink it, they couldn't bathe in it, and it just took a long time before this was fixed. And it's still not completely fixed, but at least it's getting better, and they're still trying to help.